Hello, everyone. Wish you a very good evening, and I welcome you to the NZ Knowledge Series. We are now starting with the second week in this series, and I'm really excited to welcome each one of you into this series. We've had a lot of good feedback in the previous session, and we're going to, take your feedback and improve on it much further, so that you receive good, valuable takeaways from our session. So really quick, if you're tuning in for the first time in our series, I'd like to uh, tell you that the knowledge series is brought to you by the METRI program under USAID. METRI stands for Market Integration and Transformation for Energy Efficiency. So NZEB is one of the initiatives under this program, and we want to accelerate the dialogue on net zero energy and really bring to you various tools, technologies, projects, policies, etc. to do with NZEB, so to spark interest and curiosity about NZEB. So without further ado, I want to jump right into the webinar that we have today. So we have today a conversation with a panel of experts on this project called Unnati. Unnati is the name of a building. It is a commercial office building for GCPL located in Greater Noida. Myself, I am Deepa. I work for EDS. I lead all the education related initiatives at EDS. I'm an architect and also a green building professional. I will be the session moderator for this webinar, and with me I have expert panel here. If you can see them, you can say hello to them. I have architect Ashok Lall, who is the owner. I have architect Ashok Lall. He really needs no introduction. However, I am really honored to introduce my expert panel to all of you. Ashok Lall is the owner of Ashok B Lall Architects, which was established in 1981 in Delhi. The practice has executed projects for educational research institutions in many parts of India. And he specializes in low energy sustainable architecture. He's engaged in several initiatives for the improvement of public spaces in cities and affordable housing. On this project, Ashok sir has been the captain of the ship. He has steered this project in the right direction, making sure all the different sustainable strategies do get implemented for real in the building. So he has been the flag bearer for this project and has led the entire team towards executing this high performance building. Next, joining him is Vevaik Mahajan. He's the managing director of UEDC. He's an engineer, having over 16 years of industrial experience in the field of MEP and fire as well. Having worked in US and India, his expertise is in the healthcare, institutional, industrial, and commercial sectors. He has excellent understanding of BIM software and is also well versed with international codes and standards. Vivek has been instrumental in designing and implementing the radiant cooling and heating system in this building. Basically the entire MEP, in this building. It is very interesting to see how the MEP is actually integrated into the building design, and we'll learn more about it in this webinar as he speaks. Joining him is Mariyam. Mariyam is a senior green building analyst working with EDS in the green building facilitation team in Delhi. She is an architect and her interest is in expanding the realm of integrated passive design and has expertise in environmental simulations. On this project, she played the role of the lead coordinator and consultant, and she really ensured that all the green building strategies are truly integrated into the building and guiding the team further down the road when it comes to various green building strategies and under the lead version 4. So you'll hear more about the various things that went into the building from her. So before we go on to talking to our panel, I thought I can just give a brief introduction to what this building is about, so you have a context. So first thing is, Unnati is the name of a building. It is an office building for Gainwell CAT actually, which is a heavy engineering manufacturing firm located in Greater Noida, which has a composite climate. The construction of this building was completed in 2018. It's a 3-story structure, which is ground plus 2, with an area of about 53,000 square feet. And this building is part of a larger 5-acre industrial campus. So to just give you a quick overview, there's a long site and there are 3 structures on it: a DG shed, a workshop. This is primarily an industrial building, so there is a workshop and then the office. We will talk more about this office building, which is the highlight and which is the high performance building. The project has achieved a lot of recognitions. The first building in India to achieve platinum certification under LEED version 4 BDC new construction rating system. Version 4 is very stringent, and this project has gone above and beyond to achieve various benchmarks. And of course, it's ECBC compliant. Now, this is very important. Why are we even talking about this building? The title of the webinar series says Net Zero Energy Building, right? And this building is not net zero. It's not really quantified to be net zero, but we want to talk about this building because it is a high performance building design. It's an example of how a high performance building design can be implemented in a composite climate zone. It's also an example of an integrated design approach. Such outcome is only achieved if there is a holistic thought process and all project team members are on board from the beginning. And of course, this is an excellent example of climate responsive architecture. And of course, it has a low energy cooling system, which is a radiant system, which we will be talking about. All of these aspects are integral to a net zero energy building design. Only when we take this approach can we really meet the net zero energy goal. Renewable is the last leg in the process, which this building also has. So we are going to talk about all the energy conservation and energy efficiency strategies and approach, which this building is an exemplary example about. So with that, just briefing you on the client vision, and then moving on, we will move on to the panel to talk to them about the project. The clients had a clear vision that they want to develop a world-class facility for their employees that is ecologically responsible. The clients are well aware of the impact of construction on the environment, and hence they were very clear on their commitment to sustainability, that the office building that they will build and they will occupy has to be something which is ecologically responsible. So sustainability was clearly a vision that was communicated by the client. Having said that, now I want to have a conversation with my panel, starting with Ashok sir. If you can brief us the strategies, the approach and workflow for this project. The vision is one thing, but exactly how this vision translates into actual architecture, and what are the different strategies that went into the building. So if you can just walk us through it, everyone can get a good picture of the building.
Okay. Well, the big idea in ecologically appropriate or sensitive design or responsible design belongs to two sets. The first set is minimizing greenhouse gas emissions, and that means that you emphasize energy conservation, and you emphasize energy efficiency. You also harness as much as you can afford solar energy. In addition, in the environment around the building, you sequester carbon through plantation and create an experience of the ecological presence of the building by making the green areas and the planted areas and the open space experientially available to the occupants and the users of the building, and that we call biophilia. The second part of it has to do with the preservation and the protection of the commons. You have to make sure that you don't spoil the air, you don't spoil the water, and you don't spoil the ground or the earth. And then over the entire complex, you seek to integrate these ideas into a single strategic design. So that's the big thing. So while we are talking about the office building principally, because that is where the very high performance was pursued, for the factory building too, we followed the same principles of reasonable comfort, of daylighting and protection from the external heat of the work environment, and also managing waste and water accordingly. And we used the roof of the neighboring building to the office building to lay out a big solar photovoltaic array to produce as much green energy as we could afford at the moment. At the moment, I think we have got 200 kilowatts generation, peak generation. We go to the next slide. And here you can see how wherever it has been possible around, on top and around the building to integrate the greenery. This diagram that you see at the moment is to do with the management of water on the site as a whole, and similarly there is a system for management of waste on the site as a whole. All of this is integrated into the overall infrastructure planning of the plot. Coming to the building, the office building, is actually very simple. Main idea here is, by the use of a courtyard system, have workspaces which are never too far away from the outside edge of the building, where you can look out into the garden and also get the benefit of daylight. So the depth of the built area in relation to the courtyard is derived from this principle. And what you see in a slightly darker yellow line in the middle is the walkway or the passage through the office spaces, and on either side of the office spaces you have usable spaces where people will work, and as you can see, they automatically come close to where there's a view, where there's outside light, and also the potential in good weather of being able to open out your windows to get the benefit of good weather. So it's a very simple principle, but it is about integrating these factors of daylight, view, and spatial planning into a system of, let's say, into a typology of building. In this case, it's a square, almost square courtyard building. The other thing that, as a part of this integration, is that there is a garden on the roof which protects the building from the sun and also gives you recreational space. There's equally insulation at the bottom, and as you can see on the right hand side, there is a forecourt, semi-open forecourt, which shades the front of the building and provides more planting space when the building is facing southwest. So actually handling the immediate space around the building to minimize the impact of a harsh outdoor environment during the summer months is part of the integration of the design. The wall, as you can see, is also an insulating wall. But if we go to the next picture, I think, can we go to the next picture? Here you can see this wall, the external envelope of the building, does many things through one simple element. What you do is you make boxes at two levels using a sandwich construction which has a thermocol or high insulation material in the middle and then a layer of concrete holding the insulation material on the outside and the inside. This is a technology called TRIC, which we were using for the first time, which we then used to make these boxes. So these boxes provide storage, they provide shading, they provide at the upper level a light shelf to throw the daylight into the ceiling and reflect it into the depth of the office space. And they also provide at the lower level an annular space, a hollow space, through which the air conditioning ducting for fresh air supply can run. So it's a single constructional system that integrates within it daylighting, distribution of daylight, insulation, and a route for the air conditioning system. This is what you might call integrated design. The next aspect of integration is the slab. We can go back, I think, is the slab of the building. As you can see, the floor slab of the building. What we wanted to do was to use cooling of the slab by laying pipes. It's called radiant cooling, by pipes that carry chilled water through the slab to store the cools in the slab itself. And therefore, the structural system of the slab required to be designed so that it can take these cooling pipes easily. And the structural system also required to be designed in such a way that you could subdivide the office space according to the requirements into small rooms, large rooms, open office, and so on, without having to relay all your services. Okay? So this meant that not only our air conditioning engineers, but our structural engineers and the architects worked together in evolving this construction strategy, because it required the integration of air conditioning, electrical systems, a system for flexible partitioning, and the structural system all in one shot. That is how we integrated it all into one system. You'll notice that this building does not have suspended ceilings over the working areas. There is a ceiling over the passage where the return air ducts occur for fresh air supply. But for the rest of it, the ceiling has to be exposed because that is the cool surface, and the people, the body of the occupants in the office needs to be able to see the ceiling. The body must see the ceiling. It is only when the body sees the ceiling that the coolth is felt as a radiant effect on the body. So the body radiates heat towards the slab, and the heat is then carried away by the chill water pipes. So it means that you have to devise a system which does not use suspended ceilings. And yet, you have all the modern services within the system. So that is the aspects I think one must emphasize of integrating all of these things into very simple arrangements. It's nothing very complicated, but it's all integrated.
Right.
That gives you.
That was a beautiful description of how, I think you've simplified it so much, but I'm sure there was so much thought that went into coming up with this kind of a simplified system which completely integrates the services in such a beautiful way that actually the section looks, I really like this section. It's very, very, this is like my favorite graphic. It's simple, it works, and high performance need not be complex and extremely, high tech in that sense. So this is a great example of that. So maybe we'll now jump a little bit deeper into the space conditioning systems. So I want to ask Vivek, you are the MEP engineer on this project. When did you come on board in the design process? What was the brief given to you? Were you told that we have to really design a very low energy system, or was it open? And can you just briefly explain how the process of arriving at the radiant cooling system?
Sure. So I was exactly on the board with Ashok sir maybe few months after he started the project, and the brief that Ashok sir gave me was exactly the same that he just stated. He would like to see the building to perform energy efficient, low down the carbon emissions, improve the thermal comfort all across the zones in the spaces, enhance the indoor air quality, add some sort of an innovation to the project, and get this all integrated with their architectural and the structural plans. So that was the start. So just to tell about the brief of the HVAC system that we have done, the entire building is provided with the standard high side, which consists of our chilled water system. The chiller that we have selected is of 100 ton. So if you have noticed on the right, the first page of the project, the total built-up area was about 50,000 square feet. And with the chilled water and the radiant, the system that we have finalized, the 100 tons gives us approximately 500 square feet a ton. As comparative, if you have, if you know that, like in a conventional building, you hardly achieve higher than like a 250, 220 square feet a ton. So the design and the building was almost the double as comparatively to the conventional building. And this is how, we lay the foundation that this is the right system and this is how we wanted to go. So the chiller that we have planned is a standard, but it's a high efficient chiller, which this coefficient of performances and the part load values was selected, were normally higher than a conventional ones. The low side system consists of a standard, VAV system, this AHU system that takes care of the air side, but air side is only provided equivalent to the fresh air that is required into the spaces, plus the latent load, because the radiant cooling when we provide, the sensible load is normally taken care by the radiant cooling. So how it happens, when the chilled water runs into the piles of the runs into the slab of the radiant. So the heat, the temperature brings down by taking this, the radiant pipe takes out all the heat, all the sensible heat by the thermal radiation. So 75% of the heat of the space is normally taken care by this piping. Rest 20% or 25% we normally provide now with the air side. So the total air side system was like only 20% as comparatively to the conventional, chilled water or the VRV system. Additionally, the air side was with the displacement ventilation, where we are discharging the air at the lower points, ensuring that we do not want a higher temperature, because the air, when it is on the lower side, when the air is supplied at the lower level, it comes in directly touch with the occupants. So when it comes to the occupant, supplying the air at the low temperature, like as comparatively to the conventional building, 12C or 14C, may overcool the people, and this gives a uncomfort to the occupants. So displacement ventilation, we raise the temperature, and the temperature of the air is normally 18 to 20 C, and then it is being supplied. So we save the energy on this part as well. Then the radiant cooling, you have pumps, just pumps. There is no air side. So we reduce all the fans, all the motors. There is no fans, no motors, no ducts. So we save a whole lot of energy from the air side and just have a set of pumps that circulates the chilled water. Again, the chilled water that is being supplied to this radiant slabs is the water that comes from the AHUs. Then it goes to the radiant looping, and then it goes back to the chiller. So we are taking the double benefit of the return of the water. So the chilled water that is being supplied to the whole system, an average is not a 6C or 7C, it's higher, it's a way higher. The chilled water running across in the radiant piping is above 14C, and in the AHUs, it's a conventional because it has to be dehumidified. Other impact of this whole system, whole design, the system is provided with the enhanced CO2 levels, CO2 control levels. The beauty of this whole system, the spaces, none of the space has a higher than 800 ppm CO2 all the times. So this is by additional 30% fresh air that we being provided right from the day one, and the DOS or the AHUs are designed in such a fashion. The other aspect is the AHUs are having a PM 2.5 filter as well that ensures the indoor air quality is always remain above the expectations. So it's a pretty decent and the neat, clean air that's supplied to the occupants. Another, during the month when there is the project is in the composite weather, like you said, there are a few months when the enthalpy, or you say the outdoor dry bulb, is not that hot. So what we do here is we have the freedom to the occupants where they can open the windows during those months and get the benefit of the economizer, either through opening the windows or through running the AHUs on 100% fresh air. So these are the benefits that we keep getting from these all integrated design.
Right, this is fantastic. So if I just quickly summarize what you've said, is that you have a radiant cooling and heating system. It's a network of pipes, and then you have network of pipes through which chilled water or hot water would circulate, and then you have a separate system to bring in fresh air from outside.
Right.
And these are AHUs, and they are also bring in filtered air, and hence not only you have a efficient way of cooling the space, but you also have very high indoor air quality. Like you said, the CO2 sensors clearly have now, there is data right now to say that the CO2 levels are in a certain, below a certain threshold in this building. So with a low energy cooling system, it is certainly possible to have a high quality indoor environmental condition as well. So there we have architecture, and then now we have the MEP, which clearly in the diagram, the ducts and the whole system is integrated into the building design. Now let's just move on and understand what other green building strategies have been implemented in this project. Because it's not just the energy side, but there are so many things in a project like water, waste, and I'm sure other aspects as well. So, Mariam, could you, tell us, was LEED certification part of the design brief? At what point, did it become part of the project? And then, can you just go on to highlight various green building strategies integrated into this project?
Right. So initially, the project was, shortlisted for the Energy Efficient Model Building Program, which was funded by UNDP, Jeff, and we was, the main organizers for that. And this was in December, 2016, December 2016, and that was when we were doing the compliance check and we were going through the checklist that we saw, that the building is performing outstanding in most of the parameters and is therefore very good to take for LEED v4. LEED v4 was very new at that time, and this was the first project that we got registered, from EDS for LEED v4. And that was when, and Lal sir was also keen on it, the client was interested in it, so we took the project for LEED v4 in February 2017. And so although, the building was excellent, and for all, the building features, we were covering all the aspects, including the MEP design and everything. We, at the site level, again, we were meeting most of the things because we had an STP in place, we were doing rainwater harvesting, things like waste segregation and all, which is the operational side of it, and housekeeping and things like that. That was made part of the design brief at a later stage when, in February 2017. Because of the energy efficient features of the design, the TRIC panels that we're using, the DGUs that we're using, green roof for insulation, the cooling system, and we have a very BMS system in place. We have access to daylight and quality views for like 90% of the spaces. Then the additional things that we did for the project was LCA assessment, because that was part of LEED v4. We also did envelope commissioning, which included, thermal imaging of the building and commissioning it to see if there are any leakages and all these things. So these were additional technical things that we kind of invested our time also in it, because it was new to us also as consultants. We had not done this for any other project. Now, the things like native vegetation, low flow fixtures, runoff, 100% of the stormwater runoff is being harvested. 30% of the water demand was being met by treated water. So all this led to a design which was very efficient. So we were able to get savings in energy, we were able to get savings. So if you look at the EPI of the building is around 60, and a conventional building would be around 150. So we were almost 59-60% better than a conventional building. And out of that, 40% of the energy generated is from the solar PVs. So in terms of energy, the numbers we are getting in energy, we were able to perform outstanding in the energy credits. We were able to perform outstanding in the water credits. And the other, aspects like the location of the site, this, high SRI things, all of this was controlled by the green roof that was there. The green roof was able to contribute in reducing the stormwater runoff, reducing the high, heat island effect, and also in energy consumption, reducing the energy consumption. So overall, the reduction in energy consumption was 59%, CO2 emissions at also, 59%, and water consumption by 70%. So if you look at the LEED score, we are still, we are having 89 out of 110 points. If you move on to the next slide, maybe it's there. and we were able to get maximum points in almost all categories of LEED, which is exceptional and very difficult to get in a stringent certification system like LEED V4. So now if you look at LEED V4.1, it is more easier comparative to the LEED V4 because of the challenges that consultants, the market is facing, and we're not able to get most of the points because a lot of things are not available in the market. Yeah.
I would like to add a little bit
Sure.
to what has explained so well. And one is that if we are talking about net zero, you can see that you can, by design only and by selection and integration of appropriate, not terribly expensive air conditioning or cooling systems into the building, by integrating illumination systems and daylighting systems into the building, you are cutting down the energy demand by 60%. You could go a little further still. You could have even better installation. You could do a little bit more, but it seems that for a building of this nature, around 60 or maybe 70% savings by design are possible, but you're still incurring around 30% still as energy demand, right? Now, if you were to then supplement that by solar photovoltaics or any other green energy source, clean energy source, you are working towards net zero. So net zero means first reducing your demand as much as possible without sacrificing the standards that you want, and then supplementing it with green sources of energy. And you can see that you can go quite a long way towards net zero just by design.
Absolutely. I think you've just summed up so beautifully that this is exactly the point we want to make, and really reiterate as much as possible in this knowledge series, that reducing the energy demand is the key thing. And by good, thoughtful, climate responsive design, as much as 70% can be reduced, like is evident in this building. So renewable really comes in the very, very last. And by integrating the services, the energy demand which is actually there in the building can be met in as much efficient way as possible. So that's really the crux of net zero energy buildings. And once this building is operational, we have data, we can actually see if this could be a net zero building given the amount of solar on the roof. The EPI here is anyways very low, which is in the range of most net zero energy buildings. So really this is an example, and I hope everyone is taking away a lot of ideas and seeing this as a possibility for their own projects to execute. So I actually, commend the whole team in how you've put together this thought, and it's actually come together in the way we see in the pictures. So since the LEED requirements have come in much later, I just want to recall the fact that this is LEED version 4 we're talking about, which is extremely stringent than the previous version 3. And even though the the requirement to pursue LEED came much later, the project, because it was well designed and well thought, it already complied with so many requirements under the stringent version 4. So that was a great advantage to the project. And hence, it was just about doing a little bit more extra to get to platinum. But then, how easy or challenging this is. That's what I want to know. And I'm sure a lot of people are listening want to know. So, Ashok sir, I want to ask you, it's clear that the client was on board in their vision and their commitment to sustainability. But that's one thing, having an idea. But then how easy or challenging was it to actually communicate this to them in terms of the ideas that you wanted to execute? Was it just easy? They just said yes to everything, or it took a lot of convincing? So what were some of the challenges in this project to execute this building?
Well, it takes a lot of convincing to do anything that is new. And the immediate feeling that a client gets is that since this has not been this kind of integration, the TRIC panels being built, normally they're not put together in this configuration. It was quite a challenge to make it work properly, get the design, the structural design, and the finishing worked out. It took a lot of doing to eventually make it happen. But since it was integral to the design idea, and it was a new thing that nobody had seen before, including us, it took a lot of explanation. And I think at a certain stage, a bit of stubbornness also, I must say. Say, well, I've done a lot of explanation, and we have many years of experience behind us, and you can talk to any of our previous clients, and I'm sure that they will tell you that this team is not going to take you for a ride. They take full responsibility for the design decisions that they're taking on your behalf. This is the platform. The consultants and their team have to say that we take full responsibility and we have the confidence. That makes people feel a bit more secure. The second thing that did come in the way was that, whenever you're thinking of an air conditioning system, immediately VRV pops up. VRV, everybody's saying VRV, ticket, and there are other alternatives, etc. And everybody shows, oh, that's half the cost of what you're talking about, this 2/3 of the cost of what you're talking about, etc. So, yes, there could be cheaper solutions just to provide what you can just say it's an air-conditioned building, but what kind of air conditioning, what degree of comfort, what quality of air, nobody has been looking at. But when you really say that you are preparing for a future, you're not designing for today or for yesterday. You're designing for the next 20 and 30 years. And you want to protect the quality of the environment by a little bit more investment. That takes quite a lot of explanation to raise the expectation from the clients of the quality of the working environment that they want, and also to argue and to show how the system design produces efficiencies that would pay for themselves over the next 5 to 6 years. That little expenditure pays for itself over the next 5 to 6 years. That takes a lot of convincing. And there are many other people with different opinions. And as I said, you take full responsibility. You have to be prepared to take full responsibility. So Vevaik and I, when the chill slab system was not working as it should work during the first season of summer, we were there at site trying to sort it out and finding out what the issues were and getting it sorted out and making it work. And eventually, now the second season is on and it's working very well. So you have to take that kind of responsibility. You have to be at the front line and say, we are responsible and we shall deliver. That gives confidence.
Absolutely. Complete ownership of this, and really courage, confidence, expertise in your craft, all of it I think is required. like you said, takes convincing and really educating the client on this. So obviously this has not been like a cakewalk for you, even though the client was committed to sustainability, but it did take so much convincing and educating them as well, with keeping a long-term vision in mind, and only then can you see this kind of end or outcome, I would say. So then, Mariam, since this is such a well thought and designed building, in what way do you think this green building compliance has added value to the project? It's already such a well designed building.
Yeah. So that's a tricky question, Deepa, because this is, I think, one of the only projects that I've worked on where I didn't have to go and face the client to convince them on anything, and I didn't have to, kind of go back and forth and convincing ki shading tumko lagana hai, insulation you need to put, and all that. Whatever we said, and that was like the checklist that we handed over to Lal sir, and Lal sir was the, he was the soldier who was fighting on our behalf. So we didn't have to face, any problems in that, and that's primarily because of him. So in terms of the value addition, the thing is, then when you see a platinum plaque, in your office, you feel kind of a responsibility that I need to maintain it, and that's the only thing, the certificate that has to be maintained, which I think will encourage them to operate and maintain the building at which, the energy consumptions and the water consumptions that we have estimated and simulated. So that is the encouraging factor which will kind of, help us in achieving the sustainability that we envision. So that's about it. I think apart from that, it's all because of the building and the design that we have got the LEED certification, and there's no as such value addition of the certification to the building. It's because of the building that the certification is, achieved.
So I think it's more of a recognition to the building.
Yeah.
I think that's the fact that you, the client, and the design team are willing to subject themselves to an objective, rigorous external agency checking what you are claiming and then certifying it. That adds a lot of value, because otherwise whatever you say remains only a claim. It does not convert into a belief, right? And the certification process, its rigor, its comprehensiveness does change the perception of the client enormously. We had the clients publicly acknowledging how they were very doubtful and very skeptical through the process and worried quite a lot of the time. But two things. One is, now they experience the place. Now they experience their work environment. And second, they know that what this building claims is true. It's completely changed their view.
Right, absolutely. So after having occupied the building, they now see that the value of this space in their maybe the whole experience of working there. So then I would like to ask Vivek that while the employees are happy being in a green building, having connection to outdoors, how easy or challenging is it for a facility team to operate this? I mean, this meaning the system, the radiant system. How easy or simple or complex it is to operate this on a daily basis?
Yeah, it's a very good question. To be honest, the system is pretty simple. It's complex if we think it's a complex, but technically there's only a radiant piping which doesn't need any maintenance. There's only a manifold which doesn't need any maintenance. It's a purely everything in this building has been put this in the BMS, and every sequence of operation is on set and it's set in the BMS. Now the biggest problem is when some maintenance guys handle the system. That's the problem right there. So, I mean, the building like this, we definitely would like to have when there is some technical operator handling the entire system and not just a maintenance guy who is, looking after the chillers and the pumps maintenance. So that's the main crux here. The person needs to be a little educated and he has to see like, all the operation and manuals and all sequence of operations of the entire systems right there. But looking into the recent days that I'm getting the trends from the site, the team is handling the building well now. So there were issues initially, but now the system has been all set and the people are trained. So it took a little time, but everything is on place now.
But that is an important thing. I think Mariyam made this point very well, that once you've got recognition and you are now, everybody is looking at you from across the globe, you better perform. And so you pay a bit more attention. I think you pay serious attention to maintain the performance of the building. And in my last discussions with the clients, I was saying that it's not a question of only maintaining the performance of the building. It's just like when you work in your profit and loss statements for your company or your growth statement for your own company, you tell your operational staff that I want to see 5% improvement in the next year. Show me how to do it. That's the way to do it. That's where to go.
Right. So yeah, exactly. Now that everyone is watching you, you have to really perform and live up to all the claims
Promises.
or the promises. Exactly. What the predicted performance has to match up to the actuals or go even better. There are many things in this project which I think is exemplary, innovative, even though there is simplicity in the design. So this is just like a question I'm curious about, so I'm asking you. Sir, what do you think is your favorite feature or maybe an aspect in this project? It could be a design feature, maybe an approach, or maybe something else. I know that all building of yours is integrating the sustainability, the thought of it, and is climate responsive. But every project is different and is special. So what is it that you like in this project?
Okay, I think the discovery of the dimensional properties of working environments, the distance from the outer skin to the middle and again to the outer skin, as something which is worked out in terms of office space requirements, small cabin, large cabin, meeting room, conference room, open office, slightly open, more crowded. But the discovery of those dimensional properties is one thing which is interesting, because it goes from a kind of a desk and cabin planning grid to discover what will work. Next, it is the idea that the electrical systems, the smoke detector and alarm system, the fire detection systems, the communication systems, the fresh air systems, the thermal cooling system from the radiant slab, the partitioning systems, and the external window system can all be integrated to give you flexible planning. Even while we were building, many aspects of the layout were changed and shifted as the organization was finding out unko kahan pe, where they need more rooms, where they need less rooms, where they need a larger room, and so on and so forth. It was all possible within this integrated system by just locating the partitions according to the planning grid. So I think that innovation of integrating the planning grid with all the systems, I think is the real finding. I wouldn't even say it's an achievement, it's a finding, because you keep working at it and you discover this is how it works, you know. And I think that's really quite something which is, you know, it's a replicable idea. If people learn it, they can use it again and again. One other little thing, which is to do with the air conditioning system, as Vivek was explaining a little while back.
Yes, please go on.
Air system, which introduces fresh air from the bottom. Okay. Now, in earlier projects, we had installed ceiling fans in the workspaces also, saying that there will be seasons where you don't need air conditioning, but you need a bit more air movement to feel comfortable. Now the idea of ceiling fan goes against displacement ventilation, because what the ceiling fan does is it throws back the warm air down. So what we have done in this building is provide small fans, the kind of fans that you have in motor cars, under the desk for each person, which you can switch on if you want air movement over your body. So the fan blows the air into your lap and over your chest onto your head when you switch it on, and you can adjust it to 3 speeds. That's a little innovation that explores one more dimension of cooling, which is air movement over the body.
Right, and it also gives local thermal control to the occupants, so they can actually, you know, everyone can have their own comfort in different seasons. The same thing, you know, I would like to maybe ask Mariyam. She has seen projects with the green quotient all across the spectrum, and this is, you know, one of a kind of a project. So what do you, Mariyam, briefly, is your kind of favorite feature of this project? Before you answer, I just want to take 1 second to tell all the attendees that you can start sending in your questions. We have about 2 minutes into this webinar, after which we will start taking your questions. So feel free to send in the questions to the chat box. Yeah, please go ahead, Mariyam.
Yeah, so Deepa, in spite of this building being located, you know, in an industrial area where outside you see all these glass buildings and all these, you know, buildings that look like offices from the west, you suddenly see this building where you have smaller windows, you have, you know, a lot of greenery, and you enter inside and you have a beautiful courtyard, and the occupants are still happy. And these are the same occupants who were previously working maybe in a corporate glass building, and now they are situated here. And what we heard from the occupants was that they look forward to work here on the Mondays, and they want to come back and work in this office. They like the office space more than their, you know, residential building or the previous offices that they were working in. So I think in terms of that, this is a great achievement and a message to all the architects, designers, budding architects there, that, you know, it's not necessary that you have to go for all these fully glazed panels and then only you can achieve all these views and daylighting and all these things. But you can still achieve that by using, you know, smaller windows, having lesser window to wall ratios and courtyards. And this is, I think, a great learning for me also, and something that now I can quantify and tell that, you know, these things can exist with this kind of a design.
Right. And of course, now to you, Vivek, I don't know on how many projects you get to be involved right from the beginning and have this integrated approach, but what is your sort of this key thing that you like in this project, or you think this was a value add? Any feature or anything related to approach?
Right. So I have visited this office numerous times, even after occupancy. So the two things that I like the most, one is once you enter the space, you feel a fresh something air that comes to your, to your nose, and you breathe perfectly fine air. So the CO2 levels, we have the trends from the site around the 24 hours. The CO2 levels never goes higher than 800 ppm. So I have done like many of the other buildings. I'm fixing many of the other buildings, commercial spaces, office building, where the CO2 levels I've seen is touching 2000 ppm, and the people are having a literally sick building syndrome. They complain a lot about the headaches. They complain a lot about the eye itching, not feeling good. But this building, once you enter, you feel something like a little different. That the air inside the sphere is much better and purified inside. And the other aspect is like the entire spaces are well illuminated, and it's not an artificial light, it's a daylight. The courtyard, I mean, it works exceptionally beautiful. You get 100% daylight inside, and the people have the flexibility if they want to lower down the curtains or something. But definitely the daylight comes in, and you feel so rejuvenated that you're sitting in a natural climate. It's not an artificial deep building climate that you're resisting yourself not to look, and you have a bad air or something. So these two things I like the most about the project. I mean, you feel you feel lively.
Right. Yeah, I mean, the photos are also communicating that, the kind of light quality which is there in this building is really something one has to go and experience to really appreciate it, is what I feel. That's pretty much it. I mean, we are already slightly beyond time, and it's time to take questions as well from the attendees. There are actually a lot of questions. So let's see how much we can take in the next 15 minutes. So the first question is by Akshay. Question is, was there any zoning considered for office space, like perimeter zone and core zone for the conditioning systems?
Yes, really, there are definitely the zones we have considered. The exterior zones, and where the windows and these exposed conditions are directly hitting, those are separated, and those are supplied with a little higher CFMs, so that the interior zones are completely different.
Okay, all right. Then the next question is, again by Akshay, what active measures were taken to avoid condensation on the surface of the chilled slab?
What we did here is we installed the slab sensors, and what the slab sensors are doing, they're maintaining and monitoring continuously the surface temperature of the slab, and it's ensuring the slab temperature doesn't fall below the dew point of the space. So when we are ensuring the dew point of the slab doesn't fall below the space, there is no chance of condensation here.
Okay. Another question by Shilpam. What is the function behind the feature in the courtyard? I think they're talking about that fountain. So you can elaborate.
All right, I'll tell you something about it. In the middle courtyard, there's a big pool, and it's a very deep pool of water also. At the initial stages of the design, we were thinking of using that body of water as one of the elements in the air conditioning system, as a heat sink, as a cool water store, and so on. We were thinking about it, but that pool was being built in any case as a kind of a landscape idea in the courtyard, we were not able to integrate this. I think that was, that was kind of a secondary loop. It started conflicting with the notion of the cooling tower. So this idea didn't finally translate into an air conditioning integration. But we built a fountain which rises, say, 2 stories up, and it is a trickle fountain. What it does is that it sends water up, and the water trickles down the strings and falls back into the pool. When you run the fountain over time, the pool water cools down closer to wet bulb temperatures, and this cool water becomes then a flywheel for the microenvironment of the courtyard. It keeps the courtyard temperatures from rising sharply, falling sharply, and so it serves that function. And also the trees which are yet to grow, there's a couple of trees that would grow taller, and this fountain idea, they are also there for you to experience and see as you're sitting in your upstairs office and looking across. So something rising through the courtyard and carrying water is also giving you a psychological sense of cooling, if you see what I mean, right? So that's what it does. It adds to the feeling of cool and the feeling of a cool environment.
Right. So then we have another question is by Adarsh. When we're using water as a coolant in radiant cooling, I think a lot of people want to keep asking about radiant cooling. Could there be challenges in the maintenance of quality of pipes, as sometimes due to certain percentage of salts or other content in water could reduce the quality of pipes over a period of time?
Well, not really. I've done the project, similar maybe like 10 years ago, and I haven't come across like any certain problems where the salt or something, because my system on the lower side is a closed loop system, so it's not an open system. So yeah, there is no such issues in that.
There's a couple of other things there. Because it is a closed loop system, it means that very little new water is added, and whatever may be the dissolved salts would, if they were to accrete onto the surface of the pipes, there wouldn't be too much. It's different when you've got lots of fresh new water coming in, and over a period of time the salt builds up. The second thing is the material itself is designed, whatever its molecular structure, I don't know the details, is designed so that it does not abet any accretion of salts on its surfaces. It remains clean, it remains flush.
Correct.
So that's a property of this piping material. So you've got to use the right piping material. That's very important.
Yep.
Right. Now the next question is, yeah, there is a reference to a picture, so let me go to that. This one. So there's a reference to this picture saying that there is one linear external shading device while there are box sections on all other windows. Is there any specific reason for that?
Yeah. There are box sections all around. This particular facade faces southwest and therefore is much more exposed to the movement of the sun falling on the face of the building. So using this device increases the shading and protects the sun from entering the windows. Otherwise, the projection itself is not quite sufficient. When the sun is setting, say after 3:30, 4 o'clock on the southwestern face, you will tend to get sun coming into the windows. So that's one thing. So it reduces the amount of sun that can come from the southwest. In addition, the pergola at the top would have creepers that would dangle. And what we are seeing as a open kind of space at the moment actually would have tall plants. It will have tall palms, fishtail palms and Nericata palms, like a jungle growing in front of the building. Okay, that again is used as a shading system as well as a system for modifying the microclimate immediately outside the building. And also it's a welcome gesture. You know, that's what architecture is about. It's about bringing all of these things together. So the veranda, a tall veranda, is a welcome gesture. The greenery is a welcome gesture. The cooling of the outside space is a welcome gesture, and so on. So it serves many purposes together.
Right. So now I think we have time for one last question. The question is by Shravya. Can you elaborate on the truss reinforced concrete panels, and can we use them in high-rise buildings?
This is the TRIC panels. Yeah.
Yeah.
Yes. TRIC panel actually is a name given to a system of making wall panels in which you have an insulating material which is sandwiched between two meshes of galvanized steel, and then you apply concrete under pressure through gunniting on the inside and the outside of it to kind of make the wall. All right. Now this can be done in any building. Low rise, high rise is not the issue at all. But it's not a load-bearing system. It is a system that holds itself up. It can hardly be used. Maybe it can be used as a load-bearing system for one-story building or 1.5-story type of building, but it's not meant to be a load-bearing wall system. It's actually just a fairly lightweight external insulating wall system, and it can be used in high-rise buildings too. There's a trick on how to do it well, all right, and how to make all the joints and junctions and how to connect it to the structure of the building. The experts who supply the system have ways of handling all such constructional details. It's not very, I mean, I think it's been practiced quite a lot in other parts of the world. It's relatively new in India, but it is catching on as people learn how to use it. It can certainly be used for high-rise buildings too.
Yep. Thank you very much for taking all the questions. Actually, there are more, and maybe we can just try to send them to you offline, and it could help answer those questions, because we are just 1 minute away from ending the webinar. So now we've come to the end of the webinar, but not end of the session. I want to thank all my panelists, Ashok sir, Vivek and Mariyam. Thank you for taking out your valuable time and sharing your knowledge, expertise, insight and experience on this project with the attendees. I am sure there is a lot of takeaway from this, and people feel that these ideas can be replicated, and these are not just things we talk about, but they are actual things that get executed in reality. I hope that this has been inspirational for people, because it has been inspirational for me learning about this project for sure. So thank you very much. And now, before we sign off, I have my colleague here, Prachi, who has this very interesting idea she wants to talk to everyone about. Yes, Prachi, you want to?
Thanks, Deepa. I'll just take 2 minutes to announce about the hashtag NZIndia contest. So what is this contest exactly? Since we've been talking about climate responsive design since the last webinar and also in this one, and we've seen so many great examples of ecological design. This is really an initiative to get everyone to notice how ecologically in sync their everyday environments are. And so daylight, for example, is one such very critical part of environmental design, as we have seen in this project as well. Very simply, more the daylight, less the dependence on artificial lighting energy. And so, in this contest, we want you to click a picture of what you think is a great daylit space, and it could be your office desk, it could be a cafe that you frequent, a library, just any building that you think has great daylight, and share it on social media with its location and the hashtag NZEBIndia. Um, Remember to use the hashtag NZEBIndia. You can use any social media platform that you like, Facebook, LinkedIn, Twitter, or Instagram. And very quickly, the rules, it has to be an original picture that you have clicked, and you have to send it by 26th May. So don't forget to use the hashtag NZEBIndia, and we're really looking forward to some really stellar images. So that's it. Thank you.
Sure. Thanks, Prachi. And the winner will get featured on our social media platform, on our next webinar, and on our website. So just click pictures, look around, see the daylighting in the buildings. It's good, it's not good. Just click and send in your response. And quickly, on 28th May, we have the next project lined up, which is the MNRE headquarters for the Ministry of New and Renewable Energy. Their headquarters in Delhi. It's a very exciting building coming up there. So we will talk about, converse with the panel, talk about what went into designing this building. So we hope to see you all on 28th May. And with that, thank you very much for attending this session, and see you in the next one. Thank you very much.